Welcome, everyone. Today, we said at the beginning of August 2026, we're going to look at the first in a 7-part series of just mastering all of the most essential GMAT math that you need. It's going to be a massive undertaking. It's going to be incredibly valuable. Today, we are doing just straight up algebra. Next time, actually, I'll be with you next time as well on August 17th, I believe. We're going to be looking at fractions, percents, ratios, those kinds of issues here. Moving forward, you'll see problems about story-based problems, any type of word problems. Then we're going to look at some of the core strategies, the idea of like looking at a problem and trying to say, how can I avoid a traditional math slog and get through this much more quickly? Keep in mind as well that we're also going to start getting into not just quantitative, but also a lot of data insights topics as well. Like next time I plan to talk about some graphs. We're going to talk about 2 parts when we took up the stories-based lessons. And then probably again, when we talk about the strategies idea, the avoiding traditional math issues. Again, a little bit of graphs along with the traditional quantitative problems. Our fifth session will be on statistics. The 6th will be on number properties. We're also going to discuss data sufficiency questions. And then our 7th and final will be strategies, again, ways to avoid the math slog that we sometimes want to not get into. So if you're interested in sticking around for all 7 of those sessions, subscribe to this. You'll get reminders, you get notifications, and you'll be here for all of it. So focusing on algebra here. Some content areas for the GMAT does test strict algebra. You've got quadratics, exponents, and absolute values. What I have seen on the focus is that quadratics, exponents, and absolute values show up most in the traditional quantitative section, where you've got the problem solving questions here. I have not seen very much, really any, of quadratics, exponents, or absolute values in data insights. Arguably, you could say that because you do see the occasional compound interest issue in data sufficiency questions in the data insight section, that arguably could say there's an exponents issue there. But those problems are not really about the mechanics of exponents. So that's a different thing. So quadratics, exponents, and absolute values, you're looking at a lot of problem solving stuff. Simultaneous equations or inequalities you'll see pretty much everywhere. And I've got one example of each today to focus on. And focus style algebra questions is in like the modern GMAT algebra questions. Yeah. So what I have is a selection of problems which, first of all, some of them just cover some fundamentals. They all cover some fundamentals. 2 of them involve a trap or technique that I'm seeing a lot more commonly on the test now than I did on the previous version of the test. So I'm hoping that this is going to be exactly where we want to be. Let's go ahead and start. Let's try some problems. I'll put up a problem on the screen. I'll give you 2 minutes to work on it. Then we'll talk about the mental process we want to go through as we're looking through the problem. And then I'll show you some options on how we could solve it. All right. Everyone take 2 minutes. Give this one a try. If you finish, type in the chat. Let me know what you would select. All right. That is about 2 minutes, and I'm getting a lot of correct answers in, which is very encouraging. Let's start with this idea just as we begin this problem, or begin any problem. Let's talk about what we want to have here. So first, just make sure you understand the problem. Then we're just going to reflect, organize our thoughts. And then when we solve, that's when we want to be very methodical. We don't want mechanics mistakes to be throwing the correct answer out from us. So you just want to think about, what am I looking at? Can I look at this problem and think, okay, this is similar to a particular problem I've seen before. How do I want to organize myself? And then be ready to burn if we get stuck, but keep it systematic and organized. So if we're looking at this, let me just jot down some notes here on the screen in terms of like what we would be doing, what we would be thinking during the test. At a glance, I see a sequence. I see one term is known. I'd want to map that sequence. And in terms of solving, I'd either one, start at the beginning, or start at the known term. And so this would be a sort of our understand, plan, solve component going on here. Yeah, I don't believe there is an integer constraint. How does that change the possible mechanics of this if we don't have an integer constraint? What are the possible concerns here? But let's assume for the moment start and say, we're going to map it. We need to go out to the sixth term, and we sort of decide we're going to brute force this and say, all right, I don't know the first term, so I'm going to give it a variable. I don't know the second term. I'm going to give it a different variable. But after that, I have a rule. After that, you multiply the two previous terms. So this would be a times b. This would be a times b squared. This would be a squared times b to the third. And this would be a to the third times b to the fifth. And we want to know the difference between the sixth and the third terms. So I want to know this. Now, if any of you are thinking, Chris, I think there's a better way, I think you're right. And we'll talk about that in a moment. But I want to run this problem with the idea of showing that even if we don't see an ideal way, if we have certain algebra fundamentals in a problem like this, we can still get through it very efficiently. Did anybody do it this way or something similar? And if you did, what would be the next step? We'd want to take a moment here. We'd want to note that the fourth term is 1. So I know this. And then if we're looking here, one of the most common algebraic maneuvers that I'm seeing is recognizing when we have a common term that we can factor out. So we factor out an a, we factor out a b, and we end up with a to the second, b to the fourth, minus 1. And it's what's inside that parentheses that I'm seeing a lot on the test right now. A recognition of a memorized and memorizable quadratic. That, my friends, is a difference of squares. We have an ab squared. We have a plus 1 minus 1. And again, we're sitting here saying, okay, I've got all of this. And now I've got to remember that I did know what ab squared is. So do I know everything? No, I do not. But I do know some things. And I do know that this is going to be everything here times 0. And our correct answer will be C, 0. Now, this is a very traditional approach. And if this is the way we go, then I want us to be able to have those mechanics, that quick common term, and then spinning into a recognition of that memorized quadratic. If we're talking algebra skills, the thing that I'm seeing a lot of right now on the test is this duo of steps right here. That common term, and then recognizing that you've got a memorized quadratic there. I'm seeing that on practically every practice test that I get from tutoring students. Now, oh goodness, see, this is the kind of stuff that I love, because we start to recognize, and this is one of the themes that I wanted to get across today. Yes, there are some problems that offer you traditional algebra opportunities. And there are some problems that honestly kind of require traditional algebra opportunities. And when we have that, we want that to be fast. We want it to be automatic. But we want to recognize that there are other opportunities as well. And somebody is saying, we just plugged in numbers. So I'm curious, what numbers did you plug? The fourth number is 1. That one's done for us. Okay, so we assumed the first term is 1 and the second as 2. So we go 1, then 2. And then after that, we have to follow the rule. So 2 times 2 would be another 2. 2 times 2 would be a 4. We're not allowed to do that. Because my fourth term has to be 1. If we want to plug in numbers, I don't think we can start with the first and second terms. I think we have to start with the third term and say, let's just say that the third term is 2. And I don't know where we started to get there. But we could say that this could work. So there's an interesting idea. Run the first 3 terms as 1. So the idea is they're not giving the precise values of the individual terms for the first and second terms, so we're allowed to choose, but we do have to choose to keep their constraint. So 1 times 1 is 1, and you end up with 1s all the way down. Does it seem weird? Yes. Does it fit the constraint they have given? Yes. And so this would be an option. Alternatively, you could say, I know the fourth term is 1. I want to move forward from that point. I don't know the third term, so I'm going to give that a variable. And so, again, just following down the rule here, 1 times x is x. X times 1 is an x again. And now I'm wondering what is an x minus x, which is 0. A lot of paths to the correct answer here. The first traditional algebra path is one that I want you to be conversant with, because there are problems that will require that. But I absolutely wanted to start today's discussion with a bit of an irony, in that this is the algebra-focused presentation, and we start with a question which technically you could sidestep the algebra if you wanted to. Even in problems where you see that there is an algebra option, always ask whether there is a way to sidestep it. It's not always possible. You do want to have things like that memorized quadratic and factoring out a common term representation at your fingertips immediately. But you always want to look. And keep in mind, I'm going to just pop it up again here. Remember that this is the first of 7. I'll be doing another one in 2 weeks, and we'll have 5 more after that. So hopefully we'll be seeing you repeatedly here. Let's try another problem. I will say that there is The formatting on this kind of went a little bit wonky in the math text thing. That denominator is supposed to look like 3 to the 0 plus 3 to the negative 1 plus 3 to the negative 2 plus 3 to the negative 3 plus 3 to the negative 4. I don't know why the math type ended up shoving the addition signs kind of almost like it's another part of the exponent. It's not meant to be. This is the addition of 5 sequential terms, each raised to an exponent. Give it a few minutes. Let's see what happens. All right, that's about 2 minutes to get some stuff started there. All right, we've got one answer in. I will say that in the previous problem, I was getting more answers in more quickly. Did this one present a bit more of a challenge? So let's talk through it. So let's take a moment. Mentally, we'd be looking at this and saying, all right, so in terms of what I have, I see my exponents. I see my roots, which technically they're the same thing. Roots and exponents follow the same rule set. I do, however, see addition elements, which means I cannot use my traditional exponents mnemonic style rules. Like, for example, multiply across the same base, add the exponent raised to an exponent, you multiply. None of those are going to come into play here. So, plan. Two possible plans. Possible plan number one, drill the algebra. Possible plan number two, benchmark. And I'm curious how we could assess the idea that without doing any of the algebra, it's pretty definitive that C, D, and E will be wrong. I'm still getting some more answers in. Feel free to go and keep sending in answers. But my curiosity right now is whether anyone can speak to why we would eliminate CDE without having to actually do the algebra yet. If we do the algebra, I'm thinking possibly common terms, because I do see a lot of repetition of base 3. If I'm thinking benchmark, what I notice in the answer choices is I have a greater than 1 versus less than 1 split in my choices. And if I'm thinking benchmarking, I'm looking at this and thing, anything raised to 0 is 1. So this is going to be 1 over 1 plus stuff. So this is going to be the square root of something less than 1. And so if we're seeing the square root of something less than 1, our result is going to be still less than 1. But we'll talk about it. We'll move into the algebra here, because that's why we are here today. Working with our common term, we could factor out any of them. We could use 3 to the 0 as our common term, 3 to the negative 1 as our common term, 3 to the negative 2 as our common term. But general rule, you want to use the smallest value as your factored out common term. The smallest value will be 3 to the negative 4. So we factor that out. 1, 2, 3, 4 addition signs here. I'll have a 3 to the positive 4, a 3 to the positive 3, 3 to the positive 2, 3 to the positive 1, and 3 to the 0. Which means this is going to be a 1 over 3 to the negative 4. And then the values inside that parentheses are something that you want to have on a memorized list. You'll want to know the powers of 2 up to 2 to the 10th, and the powers of 3, 4, and 5 up to their 4th power. We want to have those values at the top, at the tip of our tongue. Top of our head, tip of our tongue. So 3 to the 4th is 81, 3 to the 3rd is 27. Maybe I can not talk while I write, because I said 3 while I was trying to write something. And so, of course, I wrote down 3. 27, 9, 3, 1. So let's see here. 81 plus 27 will be a 108. 9 plus 3 plus 1 will be 13. So that will be 121. And now, notice now, we no longer have any addition or subtraction elements. Now we can start to rely on our more traditional exponents mnemonics. That negative exponent is really just a division inversion. And we want to recognize that this is going to be 3 squared over, or let me write out the one next step. It's 3 to the 4th over 11 squared, which becomes 3 squared over 11, which is 9 over 11b. I will again say that it is not an accident that the traditional brute force algebra approach for both of the first 2 questions that I selected were heavily reliant on recognizing when we need to factor out common terms. All right. What's up next is a version of a data sufficiency question that we have here. This would be the presentation you would have on the test. If you are not familiar with this question type yet, because you are just beginning your preparation, note that the answer choices have a logic to them. The answer choices require that you address whether the statements work individually before doing anything else. And the idea is that you're supposed to use statements 1 and 2 to try to answer the question, how many motorcycles are in this parking lot? Again, as is our usual, I'll give you the 2 minutes. Let's see what happens. Getting some correct answers in. It's very interesting to me which problems we're solving more quickly and which ones are taking more time. It is interesting that the problems that dealt most heavily with the exponent mechanics and that really did need an traditional algebra approach for the one final answer is the one that took the most time. Be fairly consistent with experience as well. All right. So we'd be looking at this and be thinking, all right, I have essentially here a 3-variable idea. I have trucks, I have cars, I have motorcycles. So as I'm thinking here, since they want motorcycles, do I need 3 independent equations? The GMAT will play on both sides of this traditional algebra rule. The idea that you need as many independent equations as the variables to solve for the value of the variables. Now, that assumes that you are trying to solve for the value of each individual variable. Sometimes not. In this instance, since we only need the variable m, there might be a way around needing 3 independent equations. And based on the answer, something that a lot of people have found that. And then in terms of the solve here, we're going to be very, very careful with the way we set up our work on paper. I'm going to make sure that I have addressed the question itself. Well, first of all, my information. I have trucks plus cars plus motorcycles has to equal 81. I want to know the value of motorcycles, and everything in data insights is about how much can I do before I get into the minutia, the mechanics of the actual answer choice. The data sufficiency version of that mindset is, yes, they phrased it as how many motorcycles are there, but I could just as easily think about this as if I get trucks plus cars, I'm good to go. Like if you tell me trucks and cars equals 50, I'm done. I'm not seeing a reason to start with one statement over the other. 30 more cars than trucks in the parking lot. So you have more cars, so you got to add on to the number of trucks. Cars will equal trucks plus 30. And I'm like, So close to being the c plus t that I wanted, but it is not. It is not the c plus t that I wanted. This will not be sufficient. Stopping there, I think, would be all right. We know that statement 1 is not sufficient, so we know that it cannot be choice A, it cannot be choice D. You could, if you want more reassurance, I'm going to do this in sort of an orangish color because it's sort of like an optional idea. Say, all right, I can take my equation from the prompt, and I can take this equation that I have here, and I can stack them and add them. The t variables will cancel, and I'll be left with this. That'll be what, 111? But at that point, I don't see a way forward. And so at that point, I would say maybe not sufficient if I didn't realize it earlier. Again, I am seeing a growing trend on the GMAT of opportunities to work with simultaneous equations and work with simultaneous inequalities where recognizing the ability to stack them is becoming more common. Looking at our second statement, the number of motorcycles is half the total number of cars and trucks. I can take a moment and just say this, get rid of that fraction, multiply both sides by 2. And now I can go, okay, that's not a value for t plus c. And so we might be tempted to say it's not sufficient. But that temptation would be risky. Always go back and try to use the information you've been given. We recognize that those two things are the same. And so I can just replace that t plus c in the original equation. And we can stop there and say statement 2 alone will be sufficient. They are doing more problems that I've seen recently, playing the game of, and again, they will play on both sides of this. When do I need as many independent equations as variables? When do I not? All right. I have one last one for us. I'll be very intrigued to see what happens here. Let's give this one a try. Okay, a little over 2 minutes. I'm getting some choices in. I want to be very open about the fact that when I crafted this question, it is not a perfect replica of how I'm seeing the GMAT run some traps recently. One particular trap. It's not a perfect replica of it. But I hope that this will give you exposure so you can watch out for this trap in the future. One issue in this, I believe, is just a pound for pound replica, kilo for kilo replica, whatever units you want to use, I suppose, of something that I have been seeing the GMAT do very recently. So we come up here. Absolute value stuff. We know this is going to be fun. So we start with the idea of, let's work with a simple one. Absolute value of y plus 1 equals 3. We may just be able to visually look at that and go, okay, the options there are 2 and -3. 2 plus 1 gives me the +3. Excuse me, -4. -4 plus 1 gives me the -3. But for giggles, and by giggles, I mean previewing something that's going to happen on the other one. We talk about what happens in the two variations. What happens if y plus 1 is non-negative? What happens if y plus 1 is positive? Sorry, my goodness. What happens if y plus 1 is negative? What I was about to say is that it's very common to phrase the non-negative part as positive, but just be aware that we have to incorporate the possibility of 0. 0 is non-negative, but 0 is its own absolute value. If y plus 1 is already non-negative, then the absolute value doesn't do anything. We drop it. We subtract a 1 from both sides. We get y equals 2. If it is negative, however, we need to replicate the effect the absolute value would have, which means we need to change the sign in the same way the absolute value would. We do that by multiplying by -1. Distribute that -1 through. Add the 1 to both sides. Change the sign. And so these are my options for y. This one is going to be a little less pleasant. We again go with the non-negative versus negative options. If x plus 3 is not negative, then the absolute value wouldn't do anything, and we merely drop it. Add a 3 to both sides. Subtract the x. And we end up with x equals 2. All good so far. Now on the negative side, again, if x plus 3 were originally negative, we have to change the sign the same way the absolute value would. Distribute that minus sign. Add a 3 to both sides. Just for giggles, add an x to both sides, and we end up with x equals 0. And it's here that we have found the first trap. I'm curious if someone would vocalize in the chat, type in the chat, not really vocalizing. What is this first trap? Everything that happened on this side was based on the assumption that x plus 3 was negative. But if x is 0, x plus 3 would not be negative. So that means that this is never happening. Yeah. I'm seeing two responses to that. One response is the path that I took, showing that x equals 0 is not 0 because 0 plus 3 is non-negative. The other response is taking advantage of the fact that you can just plug your x result back into the original equation, and you would get a negative number on the right-hand side of that equation, which you cannot have a negative result for an absolute value. So that's our first trap. The fact that the product here is not actually going to be 0 because 0 was never actually an option. The next trap is one where, again, I think there could be some debate on how the GMAT would actually run this trap. Is it safer to just square on both sides and solve? That would be interesting. I've honestly not really come across too many problems where squaring on both sides would be faster. And I'm hesitant to endorse that because it's always risky when you are working in a problem which has a positive versus negative risk, and you do something which deliberately obscures the negative outcomes. I would have to give that some more thought. That is interesting. That's some food for thought. Thank you for bringing that up. Yeah. Coming back though, first trap here, giving you a result that actually is not possible. That is when they are at their sneakiest. Doesn't happen often, but, or I should say, it doesn't happen often with the algebra. It definitely does happen if they give you certain constraints, like they might have told you that x is a positive integer, and then hope that you will forget that x has to be a positive integer, and that's another reason why x could not be 0. The next trap here is when I specified unique solutions. Arguably, you could say that 2 and 0 are a unique solution for x, and 2 and -4 are unique solutions for y. But my intent here was to look at this and say, those are duplicate values. Should I be counting them? Should I be counting both of them? And the intent is to say, do not count both. And so you would actually only want to use one of your 2's and that -4 to get -8. Now, if that feels unfair and that there is some debate around the intent behind the word unique in this context, I feel you. I would be okay with that. I put this into this problem specifically to highlight something that I am seeing more recently, where the GMAT is developing and designing more and more problems that heavily rely on recognizing when we should and should not overcount overlapped results. That is something I'm seeing a lot more of here. And so my intent was to look at this and say, wait, 2 and 2 are duplicate solutions for your variables, so we should not be using both of them. We should only use one of the 2's. So you got there. I don't, for anyone who answered A for this one, if you feel that I'm being unfair about the language there, I could have some debate on that. I could respect your position on that. I just wanted to highlight a trap that I'm seeing very, very commonly on the GMAT now. Be aware of duplicate results or duplicated numbers and problems, and be thinking, am I supposed to be counting all of those duplicates? All right, my friends. I hope that you found this beneficial and fun here. One last thing here. Just going to put this slide up all the way through here. Make sure that you review all your problems. Make sure that you use explanations very, very sparingly. you should stay away from an explanation for as long as you possibly can. In fact, ideally, you find out what the correct answer is, and you do one of two things. You either had it correct, in which case you put it aside for a moment, or you had it wrong and you think, now that I know what the correct answer is, could I find a path to the correct answer on my own? Could I reverse engineer what should have happened to get me to that correct answer? Then, if needed, look at the beginning of an explanation for just like the first one or two steps. Remember that an explanation shows you how someone else would have solved the problem. You want to use an explanation of, okay, I just need the first step, and then from the first step, can I figure it out from that point forward? Once all of that is done for the questions that you answered incorrectly, then look at the explanations for the ones you answered correctly and ask, is there a different approach? Is there an approach that could have been faster? And I hope that the first problem we did today, where you had that whole path with there is the possibility of recognized and memorized quadratic there and working through that, but we could have just said, let's make the third term x. And so you should do x times 1 times x times 1, and you're just done. I want to remind you, this is the part 1 of a 7-part series. Subscribe and get notifications for the other 7 parts. They're going to be happening every 2 weeks, I believe. And keep in mind that we always have the opportunity to do trial classes for free here. So you can take a GMAT or GRE class for free. We have a whole wealth of free resources as well. Definitely good things to get you started if you are just getting started on your GMAT journey. And then finally, we're on some pretty significant opportunities for discounts on courses. You would want to check that out. That'd be good. What level of difficulty these questions have? The first one would have been fairly moderate difficulty because you do have the opportunity to just number test your way through it. The second one with all of those negative exponents added together, that would have been definitely hard to very hard. The one with the absolute value would have been a monstrously high difficulty rating. And the data sufficiency one would have been fairly moderate to hard, because a lot of people are going to think that you need both statements combined to get through the solution of that, when in fact you only needed one of them. So everything here today is based off of problems that would have a moderate to hard to just truly abominable difficulty ratings. Yeah, so I hope you found it beneficial. I hope you had fun today. Thank you all for participating and being so active in the chat and working through the problems here. I hope you enjoyed it, and I hope I will see you again in 2 weeks. Thank you very much, everyone.